days. And as usual, I'll start out with the quiz that was given last time. This is problem number 8. I just asked you if it's a one-sided or two-sided hypothesis, and it's all coming out of word claim. And the exercise number 8, it looks like they are wondering that if the mean salary, which is called mu, is equal to 46,000, if it's equal or not. Well, looks like if it's a equal sign, then I put this in H index 0, and the alternative to H0, which is H index 1, will have not equal to 46,000, maybe smaller, maybe larger, but the point is when it's not really equal, then this H1 could be either on the left or on the right side, and that H1 is actually broken into two pieces, into two sides, so we call it as a two-sided hypothesis. And that was the quiz question. So is it one-sided or two-sided? And well, the answer is two sides here for the hypothesis, because it's either going to be less than 4,600, which is here on the smaller side, or greater, which is on the other side. And actually, this gives us a start to solving our exercise with sample size 65. And also it has the sample mean here, which is 45 something thousand, 45 and 678, as well as sample standard deviation sigma that we have here as a 9,900. So we have these numbers placed here, and then we're gonna utilize formula for the z-square, right, which is x minus mean divided by the standard deviation over square root n, and since the sample is present, then it's going to be actually average for the whole sample, the sample mean, which is present in here. And then I need to also get the alpha or significance level, split it into two equal pieces, because we have two-sided hypothesis. So it'd be 2.5% or 0.025 for the area of each of this little tail. So question is, what is the border line? What is the cutoff for that? And I'm gonna get the Triola formulas and tables and get that 0.025 located somewhere in the middle of this pages, right? Remember, we always start on the top, and when you continue to go down, the numbers start to increase. We need 0.02, so it's going to be someplace here. They're always 0.2, and if you get a little bit farther to the right, you're going to see exactly 0.25 present here, and it will correspond to -1.9 and then 0.06, right? So as usual, on the intersection of row and the column, we get numbers, and then we compose that minus 196 from part of hundreds and the tens. And since picture is symmetric with respect to 0, because it's normal distribution, then everything is going to be symmetric. So the area we already noticed, we split it into two equal pieces, and the other z-score on the other side will also be symmetric. So now looks like it's time to calculate a z-score using the formula that we already utilized last time and prior to the last time. And this will be using the sample mean 45,678. Now I have to subtract population mean from it. And the population mean is always coming out of claim, actually from the hypothesis. So this will be 46,000 even. And then denominator that will contain a standard deviation of 9,900, which is also divided by the square root extracted from sample size of 65. So now the part that I have to use a calculator to divide, and I want to make sure that I put those parentheses as usual around my numerator and denominator. So let me get a scientific calculator and get this used for our fraction. So please get a calculator and see what your z-score will come out to be. So here I have my numerator entered, and then divide by, in the parentheses, denominator is 9,900 over square root from 65. So here's our result. It's some negative number, so it'll be minus 2 point, actually minus 0.262, etc. So where is location of this number on my picture? It looks like it's a little bit less than 0, so it's someplace here, isn't it? Because we have 196, which is way farther away from 0, so it definitely does not hit area of H1, but it sits in that bigger region, which is called H index 0, and therefore I say yes to that H0, we're in it, and no to H1 because we're not in it. And notice that I just said yes to the claim. So we supported that fact. They claimed here in exercise number 8 that the average starting salary for college graduates that took statistics course is equal to $46,000. So we did the statistical research and we proved that. It's very interesting, isn't it? So it looks like this procedure of finding z-scores and that come from the sample and then test and vary hypothesis, every hypothesis possible, is always going to be the same thing that is happening here. So what I can do is take a look at the previous section. Remember, I promised to also look at the section we have before, and what we have before is the section 7.3. That also discusses the z-score, but in a case if we don't have a mean but a proportion. And if you recall the formula that we had just now was this z-score story that was dealing with x minus mean over standard deviation, then we can replace the mean with n times p and the standard deviation with a square root extracted from npq. That's for the binomial distribution, the formulas that we already utilized prior. But notice that now, if I divided each of these terms in numerator and in denominator by n, x over n, which is going to be the proportion, and I divide, say, 2 out of 10, so it's got over total, and this is coming from sample. And then I divide by n, so I just get a p for population. And in denominator, if I put that n on the bottom, I'll get pq divided by n will be exactly the result for my z-score that they show us in here. And that's the formula that we're going to use in that new section. So I'm just going to take an exercise and test some claim related to proportion, because we already know that sometimes it makes no sense to talk about population mean, but with proportions it's working. Like, for example, in a problem 3 that deals with the testing of 2,500 brides, they wonder about whether they're willing to spend less than $750 on their wedding gown. So looks like in this exercise, they had a sample, big sample, 2,500. And they also working with the fact that 60%, so that's from the sample, we have a sample proportion, 0.6, that are planning to spend less on the wedding gown. So what they want is to also consider the claim. So in the claim, they say that mean, which is actually, they don't say word mean. I should be careful, right? They say less than 62%. So it's not a mean, that's P. That's a proportion, which is less than 62%, are willing to spend that money on the wedding gown, which is less than $750. So they decided to put such a claim here. And this starts the process because now we have H index 1 here, right? As H0 will be its opposite, and it must contain that equal sign. So that would be instead of less than, greater than, or equal to 0.65. So it looks like in this formula, I also utilizing Q, the complement of P. So to get Q, the complement, I always subtract from 1. In other words, if we have the 62, I need to be careful that I have 62% for the P, then the opposite will be complement 1 minus 0.62. So remaining 38% or 0.38, which is Q, the complement. So the picture will give us one-sided hypothesis. The reason it's one-sided is because we make a picture of H1, which is less than, which is on the left side, and then its opposite, H0, is going to be everything else on the other side. So one-sided hypothesis here, and the last number we didn't use yet is a level of significance of 0.01, and since we're on one side, then we don't break it into two equal portions. So I need to find 0.01, and looks like we already worked with something like that, because 0.01 is right in between of these two numbers, but it is not exactly in the middle. It's like 100, which is closer to 99 rather than to 102, right? Therefore, I'm going to have to use the row with minus 2.3. I hope you can see it here. And the column under 0.03. So negative 2.33 is our so-called z-score. Maybe I can clear this a little bit. So the z-score determined by the area comes out of these nice tables. And then we are going to go to the sample and compute the actual z-score. It looks like now we have everything that we need for that in terms of numbers. So my numerator will have a p with a hat, 0.6, minus the population proportion is 62.62, because it's always coming from the hypothesis. And then I need to divide this by a square root from a fraction with a p 0.62 times its complement q, which is 0.38. And this is divided by sample size and denominator by the big number 2500, right? 2500 is what I put in denominator. And also, before to enter this in the calculator, I want to make sure that my numerator is in the parentheses, because denominator is already inside the square root, so I don't really need parentheses around it. Well, so let's do this. 0.6 minus 0.62 parentheses divided by the square root, and there will be a big square root. 62 times 0.38, right? And then this is over 2500. So I got a z-score, and this is great. We have negative 2.060, etc. So this is what I need to compare with my critical value on the border, and the tool is going to be closer to 0 than 2.3, right? So we always want to make sure that we see if we in the H0 or in H1, because that's the key part here. We want to see that we are not in H1, we're not beyond 233. So we're in H0, and that's why what I'm going to do is, this is supposed to be H0, and this is supposed to be H1. I think I use very light marker, so you don't see it right now. So H0, I just said yes to, so we are here. And no, I said to H1. And since I said no to H1, it means I also said no to the claim. And sometimes people say that I rejected their claim. So we looks like going to have the statement that writes the claim that less than 62% is not being supported. So actually, it's not less than 62% that purchased this gown for less than 750. And I guess based on this observation, you can produce so many gowns, so you get to sell those. If you're in a business of selling these devices, then you can definitely go into benefit from this. So you get percent of gowns that are less than 750, and then percent that is more than 750. And it's somewhere around 62, and that's what we just try to determine. So that's very useful for the business applications. And I guess if we take a look at the variety of questions that appear in this section, then you're going to see that they all from various areas. Like exercise 4 talks about the drug offenses, part 5 says email uses, and so forth. So you can apply this anywhere to the real life, and that's the power of this type of work. So I can try one more here. For example, which one? We can try 8. Cloning survey. How about cloning some adults? And we have that sample considered of 10, 12 people. And looks like out of this sample, not too many people actually supported this idea. They say 9% only said that. So this is a sample proportion, that cloning should be okay. And I think I better write this a little bit more carefully, this 10, 12, right? So how about the claim for this exercise? Well, looks like we're going to have to test that less than 10% support that cloning process. So I will write down word claim. Then the proportion of people that support is less than 0.1. And from there, we can make all kinds of inferences. So looks like this is going to be H index 1, because it's without a 0. It's without equal sign, because we must use equal for H index 0. And actually, the opposite to less than will be greater than or equal to 0.1, and that's exactly with equal sign, so it's in my H0. So P is here, and then I need to get a friend of P, its complement Q, 1 minus P. So if we have 0.1 for P, then 0.9 will be for Q. And we got ourselves a start. We need to make a picture of our claim here, because we're picturing actually H1, and it is here on the lower side because it's less than 0.1. So H0 will be on the opposite side. H0 is always bigger region. So Now I need to put this significance level of 5% here, 0.05, right? And now based on that significance level, again, I need to get that cutoff value of Z from my tables, and I need to locate 0.05 in these tables, and looks like it's a number in between, right? It's where the asterisk points. That's right here. So it's like 500 that lies in between, actually 50 that lies in between. Is it 0.5? Am I being careful? No, I'm looking at 0.05. 0.5 is here. So it's in between 505 and 495, like 500 is right in between. There is no closer number, and that's why for that 0.05, we have a z-score with a little extra, right? -1.645, because it's in between 64 and 65, so we put like the average here. And that's what the tables actually bring us to. And then I will utilize information that we collected from sample and plug it in the formula for the z-score and get the result. So P with a hat was 0.09 minus, next is our population proportion 0.10. Again, it's always coming from my hypothesis. And then in denominator, we get a square root of this 0.10 times Q 0.9 divided by 1012, right? Just like that. So numerator, I'm gonna, as usual, put in the parentheses. Denominator, I guess, is not needed, but you can always use parentheses if you are not sure and trying to be careful, and this is never gonna go wrong. So whenever doubt, use parentheses. And then we gonna put the square root in denominator, 0.1 times 0.9 divided by 1012, just like that. So there we go. We have the answer. We have a z-score, and this is -106, and etc. So looks like we can decide H0 or H1. What do you think? Do we reach 1.64 or not really? Looks like not really, right? It's just 1.0, so it's still closer to center, to that 0 in the middle. And this means that we're in H1, and that's all we, in H0, sorry, and that's all we care about. So I say yes to H0, and no, we're not in that little tail called H1. We're on the opposite side. And I just said no to the claim. So we have made a claim about something that said that less than 10% of adults say no to cloning, and the answer is no, not less than 10% actually say yes to cloning, right? Support cloning. So the answer is it's not less than 10%, so it may be more, may be equal, but not less. So we got another denial of claim. And technically, claim could be anything. Somebody else can say more than 10%, and we can actually produce opposite claim and probably support it, but that'd be another exercise. So all these problems are analogous to each other. They all have the same structure. We need to produce the hypothesis based on the claim, make a picture of H1, and then get a z-score calculated out of our sample and see if that z-score is in H1 or in H0. And based on that, we make our inferences. So the plan for problems is the same. So I think that next time I will do more problems in here, and section 7.3 is what we're gonna continue with on Monday. And for now, I will answer questions somebody emailed to me asking what is the homework, what we should be turning in for the final exam. And for the final exam, I think we stopped at chapter 4, right? So we need to see what we did in chapter 4. And we did a couple of sections in the chapter 4. It was 4.3 and 4.4. That's binomial distribution formulas. We just saw today that NP, remember, and then the standard deviation, the square root NPQ. So those are favorite formulas for standard deviation. Then we moved to chapter 5, and we looked at sections 5.2, 5.3. Remember, in this textbook 5.1, so there's no such exercises for section 5.1 or 6.1 or 7.1, so they are just a few sentences there. So then we skipped 5.4 and moved to 5.5 and 5.6. Then we went to the next chapter 7, and we did 7.2 after 5 is 6, 6.2 and 6.3, those two sections. And we also did a couple of sections in chapter 7. Today we looked at 7.3, and last time we worked on 7.4. So for these sections, you should do homework, and just like you did before, make pictures of your problems done and email it to me whenever you're finished. So the deadline will be our final exam day, and the final is going to be a week after next. So it's Monday, I believe it's May 1st. May 1st, Monday, will be our final that I will administer by email. I'm gonna send to you problems, and you will send me back their solution with your work. So I will take a look at it, and I will give you plenty of time for that. So it'd be analogous exam as we had for the midterm, and it worked for pretty much everyone in class. So I hope the final is also going to be an enjoyable experience for you. So next week, I'm going to send you practice final, and you can actually see how I will solve it for you. So we'll prepare for it. And then a week after next, we'll have a final on May 1st on Monday, and May 3rd, Wednesday. By that time, I should have everything graded and posted on Canvas. So you will be able to see your grade for the class and for the final, and we can discuss this on that very last class meeting on Wednesday, week after next. So that'd be May 3, that'd be our last day of class. And of course, we will talk about this last weeks of class on Monday and Wednesday next week in very, very detail. So today I don't plan to give you a quiz. I think we're pretty much done with the material I was planning to cover in this class, and problems are a little longer, so I don't think we need a quiz on this. We had plenty of quizzes already, so I'll just let you go without a quiz. And relax a little bit and have a good weekend. So if you have any